Okay, 8th graders, we are on lesson 2, session 4, which starts on page 33 in your textbook. Today we're going to be describing rigid transformations, and it says single rigid transformations, and what it means by that is we're only doing one transformation per figure. Our goal eventually will be to do a series of them, like take this triangle little A right here and flip it and slide it and rotate it around and put it in a whole new spot and orientation. But for today we're just doing one translation. And our try it today says that 1 draws triangle A on the coordinate plane. He uses one transformation, a single transformation, to form triangle A prime. What transformation did he use? It doesn't even say you have to describe it. It just says what transformation did he use. And if you look at it, it can't be a translation because that's a slide. It doesn't look like a rotation. It's just facing the opposite direction, right? So it looks like a reflection because it is one. Reflection. There you go. It's a reflection. It doesn't say we have to describe it because we're going to look at different ways to describe it down here. Okay, we're exploring different ways to describe the single rigid transformations on the coordinate plane. So I just want to color them again. I enjoy it. Okay, so we have two different models. Yeah, two different ways to model it. You can reflect, it says you can reflect a figure across an axis. I'm changing my color again. Too many times. Okay. If you reflect triangle A across the y-axis, this one, you can map the figure onto its image. Oh, that's a nice way to say it. It says if you do, basically it's saying, I think it's a reflection because if you do a reflection, it will land in that same spot. That's a nice way of saying it. Yay. Here's another way to say that. You can rotate the figure around the origin. Oh, you could do a rotation, huh? I didn't even think of that. Shame on me. If you rotate triangle A 90 degrees clockwise, oh, because it's a isosceles triangle. Oh man, so fancy. Isosceles. If you rotate triangle A 90 degrees clockwise, so that way, around the origin, right there, you can map triangle A onto its image, A prime. You could also use a 270 degree counterclockwise rotation around the origin. Okay, so that's another nice way to say it. Basically it's saying if you do, the way you know that this is that type of transformation is, it's saying if you do it, it will land there. That's how you describe it. So it's what it's saying here is with the 90 degrees clockwise, 90 degrees clockwise is going to land there. But then 270 degrees counterclockwise, that's 3/4 turns. So that goes from here to here, there to there, and there to there. That's 270. Here's 90, 180, 270. Or you could just go 90 clockwise. I'll put the degrees because that's proper. And we got to be proper. Okay, so there's 3 different ways to describe that one. Using the problem from the previous page, we're going to understand how to describe single rigid transformations in the coordinate plane. And we're going to look at both models. Why is it impossible? Why is it impossible to tell whether one used a reflection or a rotation to transform his triangle? Well, does it give you any indications of which way it moved? Did it say it moved that way? Does it say it moved that way? Does it say it moved that way? No, it doesn't say anything. So, no. Nope. Actually, it says why. I should say why. They are, you know what, I shouldn't say they. Let's get even more specific. The image. Why is it impossible? The image is in the same spot with either transformation. Oh, we're in a room. Transformation. There we go. Okay, triangle A. We're on number 2 now. Triangle A is shown with its vertices. Remember, vertices means corners. Labeled as X, Y, Z. Label X prime, Y prime, Z prime first to show a reflection and then to show a rotation. Ooh, getting tricky. Okay. Well, if it's a reflection, then they will correspond by their opposite. They'll correspond this way, that like they're flipped. So that's X prime, and this is Z prime. But if it's a rotation, then this is going to stay the same because they're both this distance from the origin, so that'll stay Y prime. But Z now is the X. It's going to go all the way over here, and Z is going to go all the way over here. That's X prime, Z prime. Alright, now problem 3 says, in problem 2, which is the one we just did, that one, can you tell whether reflection or a rotation was used to transform XYZ just by looking at the image? And explain. Well, are they the same? Look, this one has Z down there. This one has Z prime up there. So the points aren't all in the same spot now, are they? So can we tell? Yes. Yes. And explain it. When the vertices are labeled, you can see they're in different spots. There you go. Okie dokie. How do labeled vertices help you identify which transformation was used to transform a figure? Well, when we labeled them, we could see that they were in different spots. It got more specific. I think that's a good word to use. Let's use the word specific. And let's use the word orientation too. Let's see. When you label the vertices, oh, I'm going to change my answer. When you label the vertices, you can see the specific position or orientation. Okay, I did work in specific. The specific position or orientation of the image. Of the image. And remember, image means the copy, the new one. Okay, and this one is for you to do. You're going to reflect. Think about the models and strategies you have discussed today. Describe how one of them helped you better understand how to solve the problem and try it. So looking up at the modelets, which one do you think is better? Really, it's the same thing, kind of. So just basically anything in the last couple pages, what was the thing that most helped you understand this lesson? Go ahead and pause and answer that question. And you're in pause because you answered the question. Good. We're on we're on page 36, and we're going to work through these together. These are our guided practice problems, 6, 7, and 8, and then you have a couple pages of green pages, independent work to turn in to me. So Brett and Sophia each perform a single transformation on figure JKLMN to form image J prime, K prime, L prime, M prime. Brett translates the figure up. He translates the figure up 4 units. Sophia rotates the figure 90 degrees counterclockwise around the origin. Very specific information. Label the vertices for each student's image. Okay, well, Brett just slid it up, so that's super easy. So he's just sliding it, and so it's going to stay the same orientation, because remember, translations don't alter the orientation, they just alter the location. So this square is going to stay exactly the same, just moved up. However, Sophia went 90 degrees counterclockwise. So her square turned 90 degrees. So this one's going to stay the same because it's the origin is the center. So that's still J prime. But now K is up here. L is right here. And M is right here. Okay, so they're labeled now. And what is another single, this is B, what is another single transformation we could perform? Well, there's only one rigid transformation left. We did a translation, we did a rotation, so now we need to do a reflection, so everything's going to flip. So J stays flipped right here, J prime J, didn't move any of the times, did it? K has flipped over right here. M is now flipped all the way up there, and L has flipped up here because they're reflected across the line of reflection, which in this case is the x-axis. There we go. I guess we should write down what we did. Reflection. There we go. Okay, 1 down, 2 to go for our guided practice. Rosa transforms figure PQRS gray. How did I get to gray? Blue. There we go. To form its image P prime, Q prime, R prime, S prime. Label the vertices of figure P prime, Q prime, RQ, S prime, and tell what single transformation Rosa used. Is there another single transformation you could perform on this figure, PQRS, that would cause you to label the vertices of the figure differently? Explain. 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 Okay. Let's see. Well, we can't flip it, can we? Can we rotate it? Nope. Can I rotate it this way? Nope. It'll change the orientation both times, because remember, this thing has only changed position. The orientation is the same. It is facing the same direction both times. So that has to be a translation. Okay, oh, I guess we should label it, huh? So Q prime, P prime, S prime, R prime, and let's see, label the vertices and tell what single okay, so this is a translation, yeah, this is a translation. Because it changed the location but not the orientation. Location but not the orientation. And the answer to this is there another single transformation? That's a no. another transformation. Would change the orientation. So no dice there. Okay, let's see what Andre is up to now. Andre transforms figure A, B, C, D, E, F to form its image A prime, B prime, C prime, D prime, E prime, F prime. What single transformation did he use and how do you know? Well, let's see how these corresponding points, corresponding vertices, line up. Okay, so A's here, B's are there, so they're the same distance apart from the line, the y-axis. So it can't be a translation because it has changed orientation. It's flipped around. Oh, it's flipped around. There we go. Can we do a rotation now, though? Nope, because a rotation, yeah, rotation wouldn't work. Because a rotation would put F now over here. So yeah, this would be this is a reflection. Because each vertices, each vertex, I think it's vertex in this context, not each vertex, is equal distance from the line of reflection. Which is, yes, I'm still going, the y-axis in this case. Smiley face. Okay, now remember when you're working on your independent practice, if you get stuck, you go back and look at a similar example up above on the blue pages. Whoa. And then, or if that doesn't help, look at the videos again, have a grown-up help you, because these are supposed to be independent practice, but sometimes we still need help. So page 37 and 38, please submit to Canvas as soon as you are able. See you later.